anyone remember, whoops, with inverse functions, anyone remember anything about those points? If the function has the point -3, -26, the inverse has the point
26, 3, -26, -3.
Thanks. Okay, so if a function has the point -3, -26, the inverse just has the opposite point. Yeah, I agree. I am not complaining. Let me remind you something. If I've got this as my function, I'm going to draw it right here. Woo! If that's my function, you don't have to draw this. Its inverse is always just reflected over. Does anyone remember what this line is?
X equals X.
Say that again? Yeah, that's the equation of a line. You guys, so therefore, because it reflects over this line, Healed, because it reflects over y equals x, my y is my x. My y is now my x. We get that, right? So let's keep going. And if f and g are inverses, that's what I'm saying. F and g, I made you this cute little table. What would g's point here be? -2. Keep going.
0,
Keep going.
1, 0, 9, 2, 28.
You guys are good. You guys, what if I asked, this is the only calculus we got to do today, to estimate f prime of 1. Wouldn't 1 be about here?
Yep.
Mr. Nelson just shouted something. I said if f is 1, that's okay. Change the y over x, change the x would get me what minus what over what minus what? Final answer? 8 over 2, which is 4. Agreed?
Yeah.
Cool. What if I ask for the derivative of the inverse when x is 5? Someone just jumped that out too, and I love it. Do you guys agree 5 is between my 1 and my 9?
Yeah.
What would be the change in y over change in x over there?
2 over 8.
2.
0 over 2.
Final answer? 2/8 is 1/4. What do we notice about these guys?
Inverse.
Ooh.
Semi.
Ooh.
1 over.
Thank you. They're reciprocals, aren't they? So you guys, this is going to be actually a really nice Friday lesson. It's going to be really nice. Today we're just prepping for it. They're just reciprocals of each other. And what AP is going to ask us is what's the derivative of the inverse?
The reciprocal.
You're going to just go find the derivative of the function, and we're going to take its reciprocal. We got this, okay? But let's kind of back this up kind of as the y. Here's what I want to do. Let's go plot these points real fast. Let's go plot this function. Do I have room to plot -3, -26? No. -2, -7?
Yeah.
Sure. -2, 1, 2, 3, 4, 5, 6, 7. -1, 0, 0, 1, 2, 9, 2, 4, 6, 8, 9. I'm just graphing f. There's my f function. And then I'm also going to graph g.
It's a tangent.
It does kind of look like a tangent, but actually, since there's only one of them, you know how tangents like this, Colin?
Yeah.
A boop, a boop, a boop, a boop. This one's just going to be x cubed. -7. -2. 0, -1. 1, 0. 1, 2, 3, 7, 8, 9. 2. What's the matter, Dar? Tar. Do your F and your G, which I like to label just to make things nice and clear, do they look like they were reflected,
Yes.
sandwiched, if you will, over that line y equals x? I'd say so. Inverses always are. My y is my x. I'm actually going to just skip this part. This is unnecessary. Boop, boop. Inverse functions are reflected over which line? You know it. Okay. Here are the equations of those two lines right here. Recognize these functions. This is x cubed plus 1. And then this is the cube root of x minus 1. No bigs. You don't need to do that on your own. Do you guys remember? For things to be inverses, for functions to be inverses, when you take f of g, which means plug in g for f, you have to get x. We did this in pre-calc. When you put f into g, you must get x. And if you get x, they are inverses. So let's just practice this. Let's go try that f of g. That means I got to go take this g, and I got to put it in where? Right for x. Perfect. Thank you, Sammy. I got to go put all this jazz in right there. So I got the cube root of x minus 1. What's that quantity being done to it? Cube it plus 1.
So it's x minus 1 plus 1.
Love it. He's saying, all right, a cube root and a cubed are going to cancel out. I'm left with an x minus 1 and a plus 1. And I just get x, and then I start feeling warm and fuzzy inside, because that's what I was supposed to get. Just proving it one direction does not completely prove it. We could get an x here and not an x there. Therefore, they might not be inverses. We got to do it both ways. So let's go do g of f of x, which means I got to go plug in f into g. Let's go plug in f into g. Do you agree I start with the cube root?
Yep.
So this is my g of f of x. I start with a big old cube root. Whoosh. And instead of writing an x, I'm going to put in all this stuff. X cubed plus 1, thanks, Nels. And then I got to finish that with a minus 1. Minus 1. Anything underneath those roots? Simplify?
Yeah, just cancel that out.
Plus 1 minus 1?
That's sure that.
And I'm left with a cube root of x cubed?
So cancel out the
Yeah, what are we left with?
x.
Do we know that they're inverses? 100%. AP's not going to make us do that. This is just a little building block for what we're going to need to do. Let's just back this up again. Ready? Let's think about this. It says the definition of inverse functions, if I compose them together, we should always get x. Cool, cool, cool. That's just a reminder. Okay, let's go draw an x cubed graph on the graph. I think we could do it by hand, but let's plot the points first. If you get my drift, because those are going to help us over here. If x is 0, what's x cubed? 0 cubed. If x is 1, what's 1 cubed? 2 cubed. Negative 1 cubed. Negative 2 cubed. Let's go plot those points. We're going to just graph a good old x cubed. 1, 1, 2, 4, 6, 8. Negative 1, negative 1, negative 2, 4, 6, 8. We got a beautiful x cubed graph. Kind of looks like the tangent again, right, Mr. Colin?
Yeah.
Yeah.
What?
Help me with the inverse. What point will the inverse have if my function had 0, 0? 0, 0. On it. What about 1, 1? What about 2, 8? Nice, you guys. Negative 1, negative 1? Negative 2, negative 8? Beautiful. Let's go plot that too. Do they have some overlapping points? Sure do. Don't mind if we do, people. So it looked like it was sandwiched over y equals x?
Yes.
Yeah.
A little bit. Little bit.
I think it's too bad.
A tad.
All right. What's the slope of y equals x cubed? Slope is just fancy for derivative, right? Let's go find what is dy dx here. 3x squared. I dig it. Where do we want to get an actual slope? Where do we want to do that? Maybe we want to do it at when x is 2. Why don't we find that out when x is 2? We down with that? When x is 2, what would be that slope then?
2 squared, 12.
Yeah. You agree to be 12? The slope of my original function, which I drew in black, when x is 2, we're saying is 12. At 2 here, would you say the slope of that tangent line is going to be pretty steep? We're saying is 12. I feel fine about that.
112.
Oh! You just said the reciprocal of 12 is 1/12. Where do we think my inverse is going to have a reciprocal of 1/12? Let's think about this real fast.
Why is it 1/12 about 2/12?
One sec. At 2, 8, the function had a slope of
8.
12.
Oh,
X equals
I
8.
see.
When x is 8, you're saying my slope is going to be 1/12? Because you're saying
The inverse.
the inverse point will have the reciprocal slope. I like it. You're down, Steph? Love. So let's go check, you guys. If my inverse was this graph, does anyone know what the inverse of? I think someone was saying it. X to the the cube, right? The cube root of x is the inverse of x cubed. It's the opposite of it, right? How can I write that as an exponent?
1/3.
x to the 1/3. Let's go find g prime. Just with respect to x, what's the derivative of x to the 1/3? 1/3 x to the negative 2/3. I love it. Is that the same as 1 over 3 x to the 2/3? Now, this is the hardest part in my opinion. We're saying, hey, the slope when x was 2, my original function was 12. We're doing great. I need to know if the function has the point 2,8, the inverse has the point 8,2. So now, I want to now know what is g prime of 8. Let's go plug in that 8 now, and we're going to have to do some mental math, people. We got this. How the heck do we handle 8 to the 2/3 power?
Power over root.
Power over root. What is the cube root of 8? 2 squared
4.
times 3. Boom. Greer, you predicted 1/12, and there we are. The hardest part, in my opinion, is saying, oh, f prime of 2 got me 12, so g prime of 8 is going to get me 1/12. To me, that's the hardest part. Note this notation. Does this look terrible? What does f to the negative 1 mean? It just means the inverse. What does this guy do? Prime. So this is saying the inverse's derivative when x is 8. This is why AP is often going to say f and g are inverses. Sometimes they will say f and f to the negative 1 are inverses, which is true. But I hate it when they do because that notation is terrible. What's up? We just did that. So we're going to do last problem, and then we'll be done today. I promise. Last problem. I'm giving you some info. I said, hey, my function f has the point, and maybe I'm even going to write this out. I'm going to say my function has the point 520 and 7,5, right? My function, these are the x's and the y's, has those points. I have not written this piece of info down yet. I've not. It says, I haven't written this or this because these are talking about slopes. Then look what it says. It says G is the what? Inverse. G is the inverse. So maybe you even write yourself a little note. That just means G is the inverse. So what points could we say G would have? 25 and 5. Agreed. They're asking what is G prime of 5. That's what they're asking. Look what the info they gave us over here. They said f prime of 5 is negative 4. They also gave me f prime of 7 is negative 5/2. If they want g prime of 5, do you agree with that? It's referring to the x value here, which would correspond to this point over here, right? So which one of these do I care about? Agreed. We got to go say, oh, if the function had the derivative of negative 5/2 when x was 7, and then my y was 5, the inverse will have the derivative of negative 2/5 when x is 5. Whew, that's a lot. I'm not going to build on that. We're going to keep going with that tomorrow. That's hard, I think.